Hi, hello everyone. Welcome to the Physionic Podcast. If you're not familiar with who I am, my name is Nicholas Verhoeven. I'm a PhD student, or getting my PhD, working towards my PhD in molecular medicine, and I've been in the science field for a number of years now. And well, if you want to know any more information, you can check out the website where it's all listed. So today I wanted to spend or have an episode kind of discussing what I've learned so far when it comes to your skin and skincare. So specifically what happens to your skin, and this isn't going to be like one of those BS YouTube videos where people are like, skin can go bad because oil is bad. No, I'm actually going to explain to you the physiology, what's happening on the cellular level that's leading to skin damage, what's leading to skin to slowly change over time, and also what we can do about it based off of four studies, one review and 3 studies that I've looked over. I guess 2 reviews, which is a multitude of studies, and 2 specific studies that I've looked at and read in detail. So I'll be going over essentially skincare up to the point that I've learned. Now, of course, this is going to develop over time, and it's going to be far more in depth, let's say, in a year from now, and then from 5 years from now, et cetera, as I learn more. But I do have some pretty juicy details to divulge in this episode. So let's get right into it. So what exactly happens to skin? Skin is primarily made up of 2 different sections. Of course, there are going to be more sections than this, but if you were to talk to a dermatologist, there's the dermis and the epidermis. So the epidermis being above the dermis. The epidermis is what we actually see. So if you're actually watching this podcast, or if you just look at your body, the skin that you see is your epidermis, and it's primarily made up of what are called keratinocytes. And these keratinocytes are the primary skin cells that usually people consider, or dermatologists consider, or just in general that we consider when we're thinking about skin cells. However, in the dermis, there are other, I guess, quote unquote, skin cells, although they're not exactly particular to skin. They're actually found in other parts of the body as well. And those cells are called fibroblasts. So this kind of exchange between these 2 cell types, although there are other cell types like melanocytes are another example, but specifically fibroblasts and keratinocytes make up a lot of what's actually going on with your skin health and being able to maintain skin health. So as I don't think it takes a rocket scientist to know that as we age, our skin starts to look different over time. So obviously a 20-year-old doesn't look the same as a 65-year-old. Now, there are reasons for that, right? The aging process in general. So let me go into some of those physiological factors as to why that really occurs. So one of the big proteins, one of the main proteins, although certainly not the only protein, but one of the main proteins that's found in skin is collagen. And that's a huge segment of the skin product world. They focus a lot on collagen, and for good reason, because collagen really allows for that kind of the strength of the skin, for it to not start wrinkling, for you to have kind of that kind of bouncy nature, youthful nature to skin is largely due to this collagen. So with aging, what happens is that collagen synthesis begins to be reduced. And some of that is going to be in combination with what I'll discover, with what I will discuss in just a little bit related to reactive oxygen species. But just for now, just know that collagen synthesis will decrease as we age. Also on top of that, collagen fibers will become more fragmented and less linear. So typically you want collagen to be in a line, and that's how it's produced by specifically fibroblasts, which is the cell type that I mentioned earlier. So these fibroblasts will release collagen, but it'll produce these 3 different collagen peptides, and then it'll wind these peptides into a helix, and then it will dump those helices, those actual fibers of collagen, out of itself into what's called the extracellular matrix, which is, as it sounds, it's extracellular, so it's outside of the cell. Now, collagen is then deposited in that extracellular matrix to allow for fibroblasts to actually hang on to that extracellular matrix, and actually for other cells to hang on to that extracellular matrix. So what happens is when collagen synthesis starts to get reduced, then you have less collagen that's being produced, and therefore you have less collagen that's being released into that extracellular matrix. As a result of that, then fibroblasts don't have as much ground, essentially, in a manner of speaking, to stick to that extracellular matrix. And if those collagen fibers start to get damaged, which they certainly can, for the reasons that I'll discuss in the next section, then you start having uneven collagen plus less collagen, which leads to fibroblasts starting to ball up. And instead of being elongated like they're supposed to, which is as they line this nice, smooth, linear collagen fiber, they start to, because the collagen fiber is no longer linear, or it's sort of semi-linear, the fibroblast will start to ball up as well, as it has less contact points to attach to the extracellular matrix, which is partly made up of collagen. So this is also propagated by the fact that as the fibroblasts are attached to the extracellular matrix, this plasticity, as you kind of pull on your face and kind of release, and for it to come back to where it is, which is not something that people, in their 70s necessarily have. You pull on their face, it's kind of droopy, right? Well, that's because these fibroblasts that are attached to this ECM, extracellular matrix, because they have less contact points, they get less stimulated by different perturbations of that ECM. So if you were to touch your skin and kind of move it around, obviously you can't see it and you can't really feel it, but within that you have hundreds of thousands of fibroblasts that are reacting to that. And without that mechanosensation, they end up, again, kind of as a double whammy, not just with age, but they also reduce their collagen synthesis as a result. Now, with that, you also have problems with the release of what are called proteases or proteinases. They're kind of the same thing. So proteases do the opposite of collagen synthesis. So in this situation, then, instead of releasing collagen fibers, winding them up into their triple helix and then releasing them out into the ECM, they'll actually release different enzymes. And these enzymes will actually specifically target and destroy collagen. So those are collagenases, but proteases will actually attack really any proteins that are in that area. So really anything that's part of that ECM. Now, clearly that's problematic because it doubles the issue, right? Fibroblasts have less contact points, and then they're releasing these proteases. And I realize maybe you're thinking, well, why would they do that? Cells aren't thinking about the grand scheme of life. They're not thinking, oh, we need to keep this person attractive. They're just reacting to their environment. I mean, cells are really just a conglomeration of biochemical processes. So it's, as I've said on multiple occasions, and I'll say on many more occasions, they're not thinking for themselves. So they're just reacting to their environment. So these fibroblasts are releasing these proteases, which is unfortunately doubling the issue that we at least experience because we don't want to look older. So the another problem, however, is skin and the sun. So the relationship to the sun. So it's not just aging, which certainly is something that's difficult to prevent, but there is something that we can do, and there are actually certain things that we can do about aging as well. But more specifically, we can focus a lot of our attention on the damage that the sun does. Now, here's something that really irritates me when I watch other videos of other people kind of explaining this stuff. They're like, well, the sun does damage to our skin. My question always is, okay, how? Can you explain the mechanism? Like, what exactly about the sun? Is it the heat? What is it? Is it the brightness of the sun? No. It's actually the radiation of the sun. So essentially everything in the world is radiating in some form or fashion. It just depends on the actual atom that's being released, or the particle that's being released. And in this situation, we're talking about ultraviolet radiation, so UV radiation, which is something everybody's heard of before. Now, UV radiation can penetrate into our cells and can penetrate into our nuclei of our cells and start to affect the DNA. So they start damaging genes in our cells. Now, of course, that has a direct impact on our cells, because then they end up not functioning correctly. Maybe they turn cancerous, which is where you get melanoma, or they may just not function very well anymore, and they may go and end up in a quiescent state, where they aren't going to turn cancerous, but they're not going to function either. And that can be problematic as well. Or kind of in the middle, they can have damage to particular genes, and some of those genes could be, for example, collagen producing genes, or start to stimulate more of protease producing genes. So exactly what we don't want. And on top of that, they can also end up stimulating, the UV radiation can also stimulate ROS, which is not from Friends, ROS, but reactive oxygen species. Now, reactive oxygen species are literally as they sound, or at least the middle word, oxygen, are oxygen atoms that have lost an electron. So if you recall in chemistry, if you've taken a chemistry course before, you've got an atom, and in the middle there's a nucleus, right? Which has neutrons and protons, and then on the exterior, way out on the exterior, are electrons. And typically you want to have a balance of those electrons to, I believe, protons, because protons are positively charged. Now, unfortunately, if you have reactive oxygen species, and the way that radiation can affect that is that they can knock off an electron, because they excite the atom, the oxygen atom, to a point where the electron ends up getting taken away, or leaves the atom. So in this situation, the oxygen atom. And with one fewer electrons, that atom will start to scavenge, quote unquote, scavenge for another electron, and it will bump into other molecules. And when it does that, it rips electrons away from other molecules, which creates an imbalance. It creates you can think of, a good analogy of this would be like a bull in a china shop. It starts just doing damage everywhere because it's just going crazy. Again, not thinking about going crazy, it's just doing it, and that's how it comes across. So in the cell, imagine that if you have one oxygen atom that's in the cell, and of course this is multiplied tens of thousands of times over, but if you have one oxygen atom and it's lost its electron, then it starts ripping that away from DNA, starts ripping that away from signaling proteins being proteins that are supposed to regulate how the cell actually functions, within the cell, how it actually communicates from one area of the cell to another area of the cell. And this can, of course, affect like collagen production, or affect some of these other mechanisms that I'll touch on as well. But really, collagen is one of the big ones. So it leads these proteins and these different molecules that are supposed to be functioning one way, it alters their structure. By removing an electron, you are essentially altering the functional aspect of that protein, of that signaling molecule. And therefore, if it's supposed to bind to DNA and express a particular DNA sequence, it's not going to be able to do that, or not do that as effectively, or maybe it'll bind something else better now because its structure is different. I mean, there's all kinds of different reasons as to why this might be problematic, but ultimately the idea is that reactive oxygen species create havoc. They start damaging all these different molecules into these different proteins. Now, another way that reactive oxygen species can be born is not necessarily by the loss of an electron, but actually by the change in orbital state of an electron moving. So let me explain this to anybody, just to remind people in chemistry that have taken chemistry. Again, we've got our nucleus, we've got our proton and our neutron, and then we've got, let's say, one electron that's just floating outside of this nucleus. Now, that electron will stay roughly within a orbital, so within a particular path around the nucleus. Now, if energy is given to that electron, what can happen is it will jump state. So it'll jump from its original orbital state to another orbital state, meaning that it will move away from the nucleus. And that actual change in energy state can actually start having effects on molecules as well, because suddenly the interaction between that oxygen atom at a higher state will actually change how it interacts with really any molecule in its base state. So in chemistry, they have base states, and then they have different charges of states. So that's essentially what we're talking about here. Now, typically people think of reactive oxygen species as the first definition, as the actual loss of an electron, and therefore that atom will be scavenging, as I said, for other molecules where it can kind of reinvigorate itself and give itself an electron back. Now, of course, that takes away an electron from that molecule and therefore damages it. So all of this affects, of course, collagen synthesis and, of course, the production of more of these proteases. Now, UV light can actually also affect a gland called the sebaceous gland. I don't know if I'm pronouncing that correctly, but it sounds smooth rolling off my tongue, so I will continue to call it that until a dermatologist corrects me. But the sebaceous gland, which is in the skin, and it's near hair follicles, and unfortunately UV radiation, because it has an effect on these cells, and it's wreaking havoc, it's pulling electrons every which way, it's doing damage to the DNA, etc., etc. That leads to a generation, so that particular gland generates oil. That's perfectly fine. That's what it's supposed to do. However, UV light can lead to an overactivity of the production of oil. Now, of course, everybody's experienced this. Everybody's got at least some sort of an idea of this, that if you have overly oily skin, what tends to happen? You tend to have more acne. The reason for that is because bacteria will infiltrate the skin at those regions where you have a lot of oil. And once you have bacteria in that area, then you have inflammatory cells. Well, I shouldn't call them inflammatory cells. You have inflammation, which is due to immune cells that end up flooding into that area, and then that starts raising it. So, of course, so if you can think of anytime you see acne or pimple or whatever, I guess in a manner of speaking, you could think of it like a mini battle occurring within your skin as your immune cells are trying to clear out this bacteria that's been led to that area because of the overgeneration of oil by the sebaceous gland. So the immune system, of course, eventually wins, and then it goes back to normal. Now, one of the problems with that, however, is that it's actually perpetuates another issue, which is inflammatory cells will actually communicate with themselves, with each other, using reactive oxygen species. I'm not going to go into all the details of that, but in all honesty, while people like to look at reactive oxygen species, ROS, as only negative, that's not the case. They're actually really helpful in terms of cell signaling as well. So inflammatory cells, a bunch of inflammatory cells or immune cells in a region like that you see in acne, can actually lead to more ROS generation that isn't needed, and therefore you end up exacerbating the issue. Again, same problem, electrons being ripped away, things of that nature. So those two factors, so you get age with the reduction of collagen synthesis and the increase in protease activity, and of course the actual structure of the collagen itself and the balling up of those fibroblasts and the effect that the sun has on the skin. So both of those are massive contributors to the aging of our skin and the clearness, the health of our skin. So what can we do about it? Well, the first thing is don't age. Should be simple, right? Just don't age. No. In all honesty, one really simple thing is what I just mentioned with the sebaceous gland. Put water on your face, in the morning, at night, especially at night, to clear off all that stuff, all that gunk that's on your face. And that's going to limit or reduce the amount of acne that you end up having, or the sensitivity of your skin to getting acne. And of course, I'm not saying that that's going to fix all of acne forever just by putting water on your face. It's not that easy, but at least any sort of extra acne that you might have because of your pores getting clogged up and those bacteria infiltrating in that area, and then the whole immune system shindig that I mentioned. So clearing out your pores is certainly important. That's a good first step. The second one is sunscreen, right? If you end up blocking the UV radiation, then you're going to be eliminating, essentially all of what I just mentioned. So wearing sunscreen is unbelievably important, not just for the trying to avoid melanoma, which is certainly a big one, but even beyond that, right? All the reasons I mentioned with the sebaceous gland and the ROS generation and things of that nature, aberrant signaling within the cell, things like that. So sunscreen will certainly protect you in that way. Now, let me mention 2 vitamins that will also help. So these would be topically put on, so on your skin, and obviously a lot of products have these, but the first one is vitamin E, which may not be written down as vitamin E on the skin product that you're using. It could sometimes. Well, you would hope that they would try to be as simple as possible. However, I will put a stipulation on this in just a minute, but let me go into what vitamin E will do. So vitamin E is also called tocopherol, TOCOPHEROL. Also actually allows for the greater synthesis of endogenous glutathione. So glutathione is an antioxidant. So as I mentioned with ROS generation, the oxygen that's going wild, the free radical, that's what it is. So it's an oxygen that's going radical. This endogenous glutathione is a particular molecule that's produced in our cells, which actually takes care of ROS and actually gets rid of reactive oxygen species while not propagating that issue of electrons being taken away from other molecules and proteins. So glutathione is extremely helpful in that regard, and our cells naturally produce it. We have genes that specifically encode for this particular molecule. So that's really cool. So vitamin E will lead to the greater synthesis of that glutathione. It also tends to reduce particular inflammatory markers. I haven't read up on this specifically, but I don't think it reduces all inflammatory markers. That's probably not something you want anyway, but it does reduce certain ones, which, like I mentioned with the old inflammation, of course, if you have more inflammation, you're going to have more ROS generation, which leads to all kinds of issues, as I mentioned. And it will also lead to reductions in vitamin E, will lead to reductions in collagenase gene transcription, meaning that you'll have less expression of collagenase, which collagenase is a specific protease or protein destruction enzyme for, as you can likely guess, collagen. So vitamin E will increase endogenous glutathione, will body-produced glutathione, that's what that means, reduce specific inflammatory markers, and will also reduce the production of collagenase out of fibroblasts and other cells as well. So really nice. I mean, that's certainly helpful. Now the other one is ascorbic acid, otherwise more colloquially called vitamin C. So vitamin C aids in bolstering collagen strength by a process known as hydroxylation. So there are two enzymes that are necessary for the hydroxylation reaction. Don't worry, I'll explain what that is. I don't remember one of them. I think one of them is prolyl hydroxylase. But ultimately, the only thing you need to know is that these enzymes, known as hydroxylases, use vitamin C to hydroxylate collagen. Now, that increases the strength of collagen because it changes the chemical bond of those triple helices that I was talking about. So remember, there are 3 peptides that are wound together into a triple helix and then exported, or then they're eventually put into the ECM, the extracellular matrix. Now, this hydroxylation reaction changes the biochemistry of that triple helix, thereby making that triple helix stronger. So the collagen fibers themselves, while before they were getting weaker with age and they were getting weaker with sun damage, this hydroxylation reaction leads to a strengthened, more stable form of collagen. So vitamin C facilitates that action through, like I mentioned, the enzymes hydroxylases. So it also acts as an antioxidant itself, so it can actually neutralize different free radicals. In this situation, we're talking about reactive oxygen species. So it will reduce the activity of those as well by giving up its own electrons and thereby neutralizing ROS. And this was just on a side note, but if you have dark circles around your eyes, sometimes that's due to poor blood flow. And apparently, this is certainly not vetted by me, and I don't fully understand exactly how this works, but apparently if you have dark circles under your eyes due to poor blood flow, vitamin C, putting topically vitamin C under your eyes will actually help with that over the day, because supposedly there's an increase in a molecule known as nitric oxide. Now, nitric oxide is, of course, a vasodilator, so that would make sense. If you have poor blood flow, that's likely due to vasoconstriction, meaning that the blood vessels are narrowing and therefore you don't have as much blood flow through that area. Now, if vitamin C does stimulate nitric oxide in that region, that would make sense, because nitric oxide is a potent vasodilator, meaning that it opens the blood vessels quite a bit. Now, here was the stipulation that I hinted at earlier. You need to be consuming, or not consuming necessarily, but you need topically, when you put it on your skin, you shouldn't be just taking vitamin C. So this is where you're going to have to do a bit of research. I think I've got it listed in one of my studies. I'm not entirely certain, but one of the studies I read, they talked about a few different versions of vitamin C, and this is likely also true for vitamin E, but certainly for vitamin C. Where just taking ascorbic acid, if it just says ascorbic acid on the bottle or on the product or whatever you're using, or if it just says vitamin C, you should be highly skeptical, because that is not absorbed very easily in the skin. So in that situation, you would want to do some research on figuring out some different versions, some synthetic versions of vitamin C, which have been manipulated to specifically be absorbed much better. So you could have a product that says vitamin C and it could be largely ineffective. You think you're helping yourself, but it's not being effective because it's the standard kind of natural, quote unquote, natural form of vitamin C known as ascorbic acid. So that is something to keep in mind. Usually it'll have like some name like prolyl ascorbic acid or something along those lines. And that's what'll give you some indication that it's been manipulated in some way, which is funny because a lot of people are always like, oh, you should stick to things that are natural. Well, believe it or not, in certain situations, scientists have figured out ways of making something that's natural much, much, much more potent and much better than its natural form. So this is one of those examples. Another example is folic acid, but that's another story. Okay, so those are two vitamins. Sunscreen, don't age. That should be easy. And hopefully that'll be helpful. Yeah, and washing your face, of course, is something just absolutely super simple that you can do that should help. So, like I said, this isn't an exhaustive list. I'm certainly going to be doing more research on this topic. I'm going to be learning much more, and of course, as I do, I'll be releasing snippets of content, and eventually I'll have an updated version of this particular podcast episode so you can get a better idea of kind of updated vitamins and minerals and how to take it and when to take it, and all those kinds of things are things I will likely cover at some point in the future for Physionic. Anyway, I hope that this was informative and certainly helpful. Certainly hope that it was helpful. And I wish you a wonderful day, and I will speak to you next time. Have a good one, guys. See ya.